everyone, I'm going to go through how to complete the Physics 104 centripetal force lab. In this lab, we're going to determine the coefficient of static friction between a penny and the surface of this turntable two different ways. The first way is by using this table as an incline. This is an inclinometer, which will tell us the angle of the turntable. So I'm going to just zero it on this surface, and then I'll place the penny on the surface as well. Now as I lift it, I'll find the maximum angle at which the penny just starts to slip. And I'm going to record that 5 times. Oh, there we go, and that is 15.28 degrees. Okay, I will repeat this 4 more times. The larger angle, that was 16.4 degrees. Trying my best here. 18.05 degrees. Oh, it's almost slipping. Try that one again. So what we're assuming here is that the friction is the same everywhere on the turntable. There we go. 18.76 was where it fell. And we'll just do one more. We'll pick another location, maybe over here. Oh, that was a little bit more sticky, so that was about 21 degrees. Okay, so we have 5 angles. We'll take the average and use that to calculate this coefficient of static friction. As you can see, it is slightly varied on the turntable, and I got a bit of variety in my results for the angle. It's also based a bit on perception as I'm lifting this and trying to hold it still the best that I can and to read the angle at the same time. Okay, so for part 2, we're going to use this disc to move in circular motion. So in this case, I am going to place the penny at different radii from the center of the circle and record the speed at which it flies off the table in each case. So first of all, I will need the radius, the outer radius of the turntable. So this is going to be from the inside of the table, this inner point, to the midpoint of this central line out here. So when I do this, I have 28.5 centimeters. Okay, and the first radius at which I'm going to place the penny is 5 centimeters from the midpoint. So I'm measuring 5 centimeters, and then I'll place the penny there. So now I'm going to shift this, start to spin it, and this photo gate will measure the speed as it speeds up. And it's going to detect it here on this laptop. Oh, I'm out of the screen. So it'll detect it here on this laptop. And when it's ready, we'll see the speed at which it flies off, and I'll try my best to hit the space bar so that I can freeze that speed. Okay. Okay, so let's hit collect. And if you can see, the velocity on the screen's changing, getting faster. And there, it starts to slide off. So I've hit the space bar, and I have 2.04 meters per second. So I'll record that for my first velocity. I'm going to repeat that 5 more times, as well at 5 different radii. So in the next radius, I'm going to place it at 10 centimeters from the center. I'll just show you one at each radii and I'll do the rest off screen. So at this point, I'm ready to take data again. So I'll hit collect, start spinning the table. Oh, it started to slide. And I hit the space bar and I'll record that velocity here. So 1.379 meters per second. Okay, then I have 15 centimeters from the midpoint. Okay, so I'm ready to collect the data. And let's go. Watching this, it'll move out more quickly at the higher radii. So found the penny, and that's 1.229. All right, now moving on to 20 centimeters. Okay, we're at 20 centimeters. Collect data again. And getting ready to go, starting out more slowly and hitting the space bar at 1.013. Just gotta grab that penny. Okay, and we're back with 25 centimeters. So placing it at 25 centimeters from the midpoint. Hitting collect, and I'll spin the table. Okay, I was a bit slow on that one with my reaction time, but I will repeat that 5 more times. And that's our lowest speed yet, 0.789. Okay, so I'm going to fill in this table, repeating each of those radii 5 more times so that we can get a good average for the velocities. You'll see that this does depend on human reaction time. It's better with a partner, but still somewhat I'm trying to hit that as quick as I can and judging for myself when exactly that penny starts to move. So with that, we can fill in the rest of the sheet using the maximum angle of the incline to calculate the coefficient of friction one way, and then using circular motion to calculate the coefficient of friction the other way, and we will compare with the percent error. Okay, I'm going to stop this now and fill in the rest of the data. Thank you.